Okay, so now let's think about, in general, how to approximate the area of a graph of a function, underneath the graph of a function over the interval from a to b. So we're going to assume that this is y equals to f of x. Now you're still going to use delta x. What's the formula for delta x? B minus a gives you this length. And because we want to build n rectangles, we divide it by n. Then it gives you the base lengths that we need for the rectangles. Okay. All right, so once you have figured out the delta x, now you have to figure out the x0 until xn. x0 would be a, and this is xn. And x0 is your a, and you're starting to move by delta x to get to the next number, right? So you can think of it like walking in the park, where you enter from gate A and you exit gate B. So here's A, and you start from here, and you take a step, you get to x1, take another step, you get to x2, take another step, you get to x3, and so on and so on, right? So every time you move, you add delta x, right? So x1 would be what? A plus delta x, you move by delta x. x2 would be a plus
2 times delta x.
2 delta x, right? And x3 would be a plus 3 delta x, and goes on and on. So xi would be
A plus I.
a plus I delta x, and eventually you get xn equals to a plus n delta x, and this is going to be b because that's where you land. And in fact, if you plug this in here, replace delta x by this one, then n and n cancels, and you get a plus b minus a, which simplifies to b. Okay, so that's something that we can check. All right, so I'm asking you purposely not try to memorize this, rather to memorize this picture, right? And the way you think is like you start from A and you just keep going by delta x and getting this. If you do this a couple of times, it's really easy to write down the formulas. There's no need to memorize this formula. Just think about this picture. Okay, so by doing that, you'll find all the endpoints. The next is that now we had a nice walk in the park, and then you're the mayor of the park, and you decide, well, that was a nice walk, but we think we need more housing. People will be happier with housing. So let's get rid of this park, right? And then build buildings, right? So what we're going to do is we have these building sites, and this is the ith building site. And do you remember what's the right endpoint? X of
ln.
Where does ln come from?
The last draft that you had.
I,
was like
if you have I, then this should be I, right? This would be xi minus, right? So that's your ith building site, and we want to build. So we want to build something over there. Now I gave you an example where you're using the right side yi to build a rectangle, but you could have used the left side, right? yi minus 1. And the difference is, depending on whether the function is increasing or decreasing, you either get an overestimate or underestimate. So let's see if you understand this. Let's say your function is decreasing, okay? And you're using the left endpoint. So here's the ith one. Let's say we're using the left endpoint to build a rectangle. Okay. So we're building a big high-rise building over this site of construction, right? And we're using this site. Now, would that give you an overestimate or underestimate?
That would still be over.
Where's it from?
If you're looking for the area, that would be over.
Yeah, we'll do this, right? If the function is decreasing and you're using the left endpoint, you're going to end up doing the overestimate, right? What if you use the right endpoint? It'll be under. If I do this, it'll be under, okay? And if the function is increasing, it'll be the opposite, right? If the function is increasing, the left one will be the underestimate one, and the right endpoint will be the overestimate one, okay? So we have two conventions that we can think of, and we want to find the formula for each. So first of all, let's think about the right sum, R sum, which means that you build a building using the right endpoint. And for R sum, it's a summation of, well, delta x will be the base length. It's base times height, right? And what is the right endpoint of the very first building site? What's on the right?
X1.
X1. So we'll be using Y1, right? So Y1 will be the height. So this is what we do. That's the very first one. What's the next building area? What's the area of the next rectangle?
Y2.
Y2, right? All the way up till the last one. This is our last one, right? What's the right endpoint? Xn. So it should be delta x times yn. Now, how do you calculate y1? You're given the function f, right? So how do you calculate y1? F of x1. Delta x times f of x2, all the way up till delta x times f of xn. And then you can factor the delta x out, which gives you the formula and that's called the right sum. Now what if we do the left sum instead? In this case, instead of delta x times y1, what should we do? Delta x times
0.
y0, because it's the left endpoint, right? So if this is y1, this should be y0, right? So it will be y0, and delta x times y1. What will be the last one? Yn minus 1. And therefore, that gives you, if you factor the delta x out, and then again use the fact that y0 is f of x0, and y1 is f of x1, keeps going until you have f of xn minus 1. So that's the formula for left sum. Once you see these two formulas, then you see that, oh, since one overestimates and the other underestimates depending on whether the function is increasing or decreasing, but shouldn't we get a better approximation if we simply take the average of the two? Right? So that idea is reflected by this thing called trapezoidal approximation. And the trapezoidal rule of approximation is simply you take the right sum and left sum and you just divide by 2. Now, what would be the formula if you actually did it? Well, if you add this plus this, you see f of x1, I see f of x1 here as well. There's f of x2, there will be an f of x2 here. And you get f of xn minus 1, that will be right before this thing, right? So everything in the middle will be paired with something else, except the very first, this one, the very first one, f of x0, and this last one, f of xn. Those two won't have any pair to double. Okay. Because one is shifted this way, and the other is shifted that way, so the last elements are not paired. Everything in between is doubled. So what happens is, if I add these two together, I have the same delta x. I can factor it outside, and there's a 2 there. But what happens inside here is that you have f of x0 plus 2f of x1 plus 2f of x2. So everything gets doubled all the way up to 2f of xn minus 1. But the last one, f of xn, again, won't have any pair to double. So that's the formula for the trapezoidal rule. Now, the question that you can also ask is, why is this called trapezoidal rule? Okay. And the answer is this. One is, so if you have a building site and you're using the left sum as one of them and the right sum is the other one. So let's say, here's my left sum. And here's the right sum. If you take the average between the red rectangle's area and the green rectangle's area, you can see that same as this one. Right? Because this triangle right here is half of their difference, right? But what shape is this thing? Well, any shape with 4 sides is called what? What's the geometric name for quadrilateral, right? And if one pair of opposite sides are parallel, we say, no, if 2 pairs are both parallel, it's a parallelogram. And if only one of them are parallel, you say it's a trapezoid. Okay? So this is a trapezoid because these 2 sides are parallel, these 2 are not. Okay? So these 2 opposite sides are parallel, therefore it's a trapezoidal shape, and that's why it's called trapezoidal. Now, you might ask another question like, is there any better way to do it than the trapezoidal rule? Is trapezoidal rule the best approximation? And the answer is no. Actually, there are better ones. And so let me talk about those. Better than the trapezoidal methods. The first one is called Midpoint Rule. And what we do is, remember the ith construction site has xi on the right side and xi minus 1 on the left side. And the midpoint rule simply uses the midpoint of the 2. How do you get midpoint of 2 given points? The average is the midpoint. Okay? You take the average, add the 2 numbers, and you divide by 2. That's the midpoint. Okay? Xi star. We're going to denote it as star, and Xi star is the midpoint of the ith construction site. Then the midpoint rule is, it looks exactly like these, except that instead of evaluating the function at either the left endpoint or the right endpoint, we evaluate at doesn't 1. Evaluate at these midpoints. So that's going to have half the error of trapezoidal. You can prove it mathematically. So that's better. Then the last one that we have to learn is called the Simpsons Rule, the Simpsons method. And Simpson was an American mathematician, and he was looking at the fact that trapezoidal rule approximates the function using straight lines, right? So he was thinking about this and said, well, you know, straight lines don't take account of the way that it's curved, right? And if we can come up with something that has the same concavity, we might be better off. So his idea was to do the following. You know that if you have 2 points, then you have a unique line, right? 2 points, you have a unique line. For one to have a unique parabola, you need 3 points. So if you give 3 points on the plane, there's only one unique parabola that will go through it. So what we do here is you take not just a single building site, but you take 2 building sites, take these 3 points, and there will be a unique parabola connecting the 3 points. Okay? Take this one, this one, this one, and there will be a unique parabola connecting the 3 points. And if you do that, then you get a much better approximation than before. Okay? So he did that and came up with his formula. And this formula actually will be the go-to method in your engineering classes. So as I said, in real life things, you can only approximate. And if your thing that you have is smoothly varying, then Simpson's method performs all the other methods in a much better way, so that when you get to use these methods in your engineering class, this will be your go-to method, and they might not even discuss the other ones. Okay? So a few years ago, I saw one professor in the engineering department that uses something like this. He had a ship wall, and there was a hole, and the water was going in, and they had to figure out how much water is coming in, and to do that, you have to estimate the hole's size, right? And he gave an Excel sheet of vertical measurements, and it was evenly spaced, and you're supposed to find the area using that information. And so you were to use the Simpsons method there. So because it's Simpsons method can be used to approximate any integral, definite integral, it can come up in any engineering courses, just out of nowhere. You might be saying, oh, now we use Simpsons out of nowhere because you want to approximate. Okay? So this is, for you, this will be the most important formula. Okay? So it goes like this. The very first one, and by the way, this is only possible when n is even, because you're using pairs of numbers. The very first is f of x0, and then 4 times f of x1, plus 2 times f of x2, plus 4 times f of x3. So this alternates between 4, 2, 4, 2, 4, 2. Now, because n is even, if you do that for even number of n, you're going to land at 4 right before the end. And then the final one. Just like the trapezoidal method, the beginning and the end wouldn't have any number in front. Okay? But in the middle, it would be 4, 2, 4, 2, 4, 2. And you divide by 3. That's how you do it.